Hey everybody, today we're going to work through section 11.3, which is going to be about the volumes of pyramids and cones. The good news here is if you've been doing pretty well with volumes of prisms and cylinders, there's only a slight difference here. So again, the real important things are to be able to identify these figures, so you're finding the correct area formulas, and again, knowing those area formulas to use. So let's go ahead. We're going to talk a little bit about the relationship between these pyramids and cones and their corresponding prisms and cylinders. So the volume of a pyramid is related to the volume of the prism with the same base and height. Okay, so it says this relationship can be verified by dividing a cube into three congruent square pyramids. So all this is doing here is showing you how this cube can be divided up into three pyramids, right? And those pyramids are all congruent. So the idea here is that the square pyramids are congruent, so they have the same volume. So if I can divide up a cube into three congruent pyramids, that tells me the volume of each pyramid is just 1/3 the volume of the cube. And so that 1/3 is really the new thing for today. So these pyramids and cones are just going to be 1/3 the volume of their corresponding prisms or cylinders. So if you can find those, today it's really just going to be multiplying by a factor of 1/3. Okay, so the volume of a pyramid with base area B. And again, when we're talking about that base area, we're talking about this here. So essentially that base, which is always going to be opposite that point. Okay, so if it has a base area B and height H, is volume equals 1/3 the area of the base times the height. Now, again, it doesn't matter if that's a right pyramid, so you can see here that height is the perpendicular distance, or if it's oblique, it's tilted. That height is really just the perpendicular distance between the point, between the vertex, and that base. So it could be inside or outside of the figure, but it doesn't change how we do the calculation. Okay. Now, so the volume of a cone, again, we're going to talk about the volume of a cone with base area B. And again, for a cone, we know that base is just going to be this circle. Okay, and then we're looking at the radius R. Obviously, that's going to be important because our base is a circle. Oh, sorry, out of the window here. Okay, and then height H, again, just the perpendicular distance. So it could go right into the center here, or it could be offset. Okay, now our basic formula is still going to be 1/3 the area of the base, there in pink. But now we know our base is a circle. So for a cylinder, we can say 1/3. The area of the base in this case is pi r squared, and then we're going to multiply by h. So we can use a little more specific formula when we're talking about a cone. Okay, so again, we're just finding volumes, but we're going to be multiplying by 1/3 now because they're pyramids or pointy. So let's go ahead and go through some problems. Okay, so for these problems, we're going to name each solid and then find the volume. Okay, and round to the nearest tenth as necessary. So here, the first thing I notice, I do come to a point, so I'm knowing going to be a pyramid. That base opposite the point is this trapezoid here. And sometimes I find that it's helpful to just kind of at least outline that base so I keep focused on what shape I have for my base. So here we have a trapezoidal pyramid. Okay. So I know my volume for a pyramid is 1/3 times the area of the base times the height of that pyramid. So here's what I'm going to do. I'm going to take the area of the base and I'm going to do that in this pink color. So the area of the base, remember we're talking about our trapezoidal shape here. So that's a trapezoid. My area is h/2 times b1 plus b2. So now the height here, I'm talking about the height of this trapezoid here, which is 6. So I have 6/2. Now my b1 and b2 are 9 plus 18. So I'm just going to go to my calculator here. And I get a base area of 81. Okay, so I can plug that one in. I'll keep it this color. Now, the height here is now the height of my pyramid, which in this case they're giving us right here. This should actually be marked as a right angle so you can tell it's that perpendicular distance. But the height of our pyramid is going to be 10. So now I'm going to plug that in. And now we can just multiply everything out. And we get a volume of 270. And now our units are going to be cubed again because we're working with volume. So 270 cubic meters. Okay, the next one here, hopefully we all recognize this pretty quickly, is a cone. Now, for a cone, I know my volume is 1/3. In this case, our area of the base is a circle, so it's just pi r squared, and I'm going to multiply that by the height. So I have 1/3 times pi. Now, this is giving us a diameter of 6, so I'm going to divide that in half to get the radius. And then the height, again, is just the distance from the vertex to the base. And here we're given that perpendicular distance, so our height is just 9. So we're going to the 10th here, so I'm just going to put this all in my calculator. Let's get rid of that glare. So I have 1/3, times pi times 3 squared, and then my height is 9. So I have 27 pi, or that gives me 84.8 cubic yards. Okay, so those are pretty straightforward examples. We're given all the dimensions we need to fill in the problems. And the next two, we're going to have to do a little bit of work to find, each of these cases, to find the height. So let's look at number 3. Here, it looks like I have 40 and 40. So the shape I have, my base down here, and again, I'm going to highlight it in just so I'm kind of clear about what my base is. Since those sides are congruent, I know this is going to be a square pyramid. So again, my formula I always go back to is volume equals 1/3 the area of the base times the height of the pyramid. So again, let's take a look at this base. So the area of my base here we said was a squared, so I just need side times side, which is 40 times 40, or 1,600. Now, for the height of the prism, we have to do a little bit of work here because this perpendicular distance from the vertex to the base is actually unknown in this case. But we're going to use a right triangle relationship to figure it out. So I'm going to pull out this right triangle here. I know this leg is the height. This is what we call the slant height of that pyramid, right? It runs along the side of that pyramid, and I know that's 25 on my triangle. Now, to use Pythagorean theorem, I need to know one more side of this triangle. And here's what happens. When this perpendicular distance gets dropped, because this is a right pyramid, it actually cuts this side in half. So if this is 40, this leg here of that triangle is going to be 20. So in other words, this distance here is half the length of that square. So now I can use Pythagorean theorem to solve. I have h squared plus 20 squared equals 25 squared, which gives me h squared is 225, and so I get a height of 15. So now I've got everything that I need to be able to solve. So volume is 1/3. We said the area of our base was 1600, and the height of the pyramid was 15. So now just multiplying that out, I get a volume of 8,000 cubic feet. Okay, but again, just had to do a little bit of work here to find that perpendicular height. And so the same is going to be true of the next example here. Here again, we're back to our cone. And for a cone, we know the volume is 1/3 pi r squared times h. So obviously they're giving us our radius here. We know that. Times pi times 16 squared. But we have to find our h. And again here, we're just going to use Pythagorean theorem to do that. I'm looking for this h. I know this leg is going to give me 16. And again, this slant height here is 34. So I can set up Pythagorean theorem. H squared plus 16 squared equals 34 squared. That's going to give me for h squared, let's see, is 900. So then I know the square root of that is going to give me 30. So I have 30 for the height of my cone. So I'm going to go ahead and plug that in. So now again, I'm just going to type in everything into my calculator. And I get, let's see here, 8,042 points, let's see, to the 10th would be 5 cubic centimeters. Okay, so those are really as kind of difficult as these will get, where you need to solve for the height, or potentially we could have to solve for a radius of those figures. So now the last thing we're going to do for this video is now being able to go backwards. So in other words, if we're given the volume, having to solve for another dimension of these figures. Okay, so for number 5, we're trying to find the height. We have a triangular pyramid here. So here's my triangular base. And we're trying to find the height of that pyramid. And so here's what we're going to do. Our volume is 1/3 times the area of the base times the height of the pyramid. So again, the area of the base, I'm going to pull that out separately. I know since I have a base that's a triangle, it's a triangle, and it's a right triangle, I'm going to use 1/2 base times height. So I have 1/2, it looks like I have 6, and a height of 8. So I'm going to get 24 for the base of that pyramid. So let's see, my volume they're telling us is 72. That's equal to 1/3 times, we now know our base is 24. And again, now we're trying to solve for the height of that pyramid, the distance from the vertex to the base. And that's our unknown. So with some simplification here, 1/3 of 24 I know is 8 times h. And then if I divide on each side by 8, I get 9. So my height is going to be 9 centimeters. Okay, so one last problem for today. Now we want the diameter of a cone. So for a cone, I know my volume is 1/3 pi r squared times h. Now the only thing we have to be careful of here is that they're asking for the diameter. Obviously when we solve, we're going to get the radius, so we just need to remember to multiply that by 2. So the volume here is 486 pi, which is equal to 1/3 times pi times, we don't know our radius, so that's going to stay, and my height is 18. So first what I'm going to do is I'm going to cancel a pi from each side. I can divide by each side. So I have 486 is equal to 1/3 of 18 is 6, and then I have r squared. So now I can divide 486 divided by 6, gives me 81, which is the radius squared. That means my radius is 9. Now, if my radius is 9, to get the diameter, I need to multiply by 2. So I'm going to have a diameter of 18 inches. Okay, so that is it for the volume of pyramids and cones. We'll get some practice with this, and this will actually be the last section we'll do before taking a quiz over these first couple sections on Monday.